everybody, and welcome to another exciting, fun-filled, expeditious episode of Radiorama, where, as the name implies, I show you how to work on radios. And today we have this Westinghouse, and it's a model unknown because there's a misprint on the back. Model H dash, and it's gone. Either the ink faded or it was never put on there. I don't think it matters that much. You can probably find it online by looking up a picture of it or something, but these are pretty common. I'm looking at this cord here. Seems like a newer cord. Don't know if it works or not. These were pretty popular. They're kind of skinny, but they've got a big speaker. And you have the ability to run a record player through them. In fact, you could buy this. I think you could buy it standalone, or you could buy it with a record player kit, and it would sit in front of the record player. I've never seen the whole thing together, but I've seen them online. So let's try it out. And by the way, don't do this if the set has a power transformer. The pilot light is coming on, so that probably means the tubes have filament, since the pilot light comes directly off the filament string. It's got a nice blonde finish, and blonde finishes are easily damaged. Woo! That is bad AC hum. Those filter caps are shot. So we already know it doesn't work, but it's got audio, which is good, and I heard radio. It's just that it's being completely covered up by bad filtering capacitors. So we're going to take the knobs off and take the back off and take the innards out, and it'll be time to do our oh-so-conventional and common recapping job. All right, I'll show you a few things about this one because I haven't worked on this in a while, and I remembered thinking last time I worked on it, I was like, this is weird. I guess it's not weird, it's just awkward. So this pilot light has to come off because the speaker stays in the cabinet, and it is plugged in like right up front here. There's like a fat pin and a skinny pin. So I know it'd be tempting just to yank the whole thing out in one piece like most chassis do, but you don't want to do it on this one. And I'm trying to remember, is there anything else holding this in? No, I think that's it. A strange design. Alright, so now I remember why I'm not a fan of these things. Yeah, they're weird and they're kind of like long and skinny and tall, but what they did in this model is like things are built in layers. So this electrolytic is sitting on probably like 5 or 6 other paper caps underneath. It's not a big of a deal because the ones we're going to replace this with are going to be a lot smaller. So it makes sense to start with those. That capacitor looks like it overheated. Its wax is squished out the other. In fact, these all look kind of crappy. Either that or it was just stored somewhere really hot. This is the most important capacitor in here safety-wise. This is the to-the-ground cap. And what that means is that one end of the AC line comes in one end, and the other side goes to the chassis. Except that's a great way to electrocute somebody. So what they do instead on most of these, except for some manufacturers that were real, I don't know, sketchy, would run it through a capacitor. And that way, the amount of current that could get to you is going to be delayed by that capacitor. It's got this big sand resistor in here, or at least a composite. I don't know what that's made out of. Sure feels like ceramic. That looks like it's okay, but looks is one thing. The fact that it came on and made noise makes me think that's probably okay. Second question is, why would you need that? This thing has 6 tubes in it, so that's more than enough to compensate for the strength for the AC coming in. So what would that be for? I don't know. Could be output related. I'm not an engineer, so. Oh, wait a minute. Look what they've done here. This is weird. Now, these are 25L6s, so we have 2 of those. I'm assuming the other one's a 25L6 because it's probably meant to be push-pull audio. Let's see what the inside of the radio box says. Wait a minute. It's got 2 rectifiers. I figured it was, I was sure that it had to be push-pull. But no, it's got bunch of, it's got 75 volts worth of essentially rectifier and output tubes. So that means we need 25 more volts minimum. Actually, we need 30 more volts because we have two 6-volt tubes. So that is what that big resistor was doing in there. The question is why? Why would you do that when you could have just used two 12-volt tubes and got away with this? I don't know. Probably it was a cost thing. I was told by some old timers that if you saved half a cent off of a radio, you were considered God. And so I'm sure that whatever they did here was all in the name of whatever lowest cost they could probably get this thing out with. Because these All-American 5-ish sets, they were sold rather inexpensively. I guess that's not necessarily true. You would be shocked at how much people paid for electronics back then, because the stuff was mostly, yes, it was on an assembly line, but you had to pay an army of workers to snip a wire, put a resistor in, do this, do that. So electronics back then were pretty expensive. But even so, manufacturers would try to find their best way to reduce that cost. This is a little bit of a nicer set. We've definitely got a pretty robust antenna on it. We've got a pretty nice tuning condenser, even though really it's just 2 gangs. That's, I guess, average. We've got a lot of room between the audio and power stage and the detecting stage. That probably helps with reception too. So what I want to do before I get started is dust it off. I can't tell, but it looks like maybe there's a little bit of cadmium corrosion. And I prefer that whatever loose cadmium corrosion is on this to come off before I start working on it. It's probably too late for me. I've been touching these radios since I was a kid. So who knows what I've done to myself. But if you can help it, you know, when you work on these things, you see something like that, it's best to try to remediate it as best you can. Well, it turned out the radio is actually very clean. A little bit of corrosion, but not much. And I started getting into this and I realized, I believe it's factory original. This is all stuck together, but you see like all those capacitors stuck underneath there? Those all got to go. Look how misshapen these things are. It's like it got really hot in here. I think it was somewhere hot. We're in California, and if you go inland at all this time of year, it's over 100. So you can imagine like stuff being up in an attic in a barn or a house or something. I think this was in a house though. It's very clean. Let's see. We have 2 values here. Green and red. 30 and 50 microfarads. We can take care of that. And then the black wires are common ground, which is that one. And if I remember correctly, like all these capacitors go to that common ground too. It's like everything goes there, which is why it's common. So I know by default that that's the black wire, so I'll just snip this whole thing out of here. I already know the values, and I'm just going to replace those with 2 47 microfarad capacitors, because why not? You can do that. You can go above or greater the capacitance as long as it's the same or greater voltage. Just don't go too crazy. You'll even help the radio a little bit if you had a little more capacitance in the electrolytics. So again, we're going to cut that out of here and maybe even use the original wires to connect the new capacitors. This is like digging. I have to dig all those out of there just to clear out the space to put my electrolytics in. And I remembered, like, these guys have a lot of grounds in here. So if you look in here, dang, it's hard to film. Got a couple of terminals like wired together. So I have a bunch of different grounds for the electrolytics in here. So I think I could just like sneak them in there. I could just run another wire from this one, but I can use that existing wire for one of the electrolytics. So let me stick those in there. Just out of curiosity, I wonder if it'll work with that squished up looking burnt up capacitor. Never know. Okay, so I've done the bare minimum to get it working again. Well, I don't have a pilot light. That's very odd. It completely lost power. Maybe this isn't plugged in good away. Let's see. That's not good. That's not good at all. What did I cut in here? That's the only explanation. I mean, is there seriously no filaments here? That's really bad. I just messed up somehow. So let me look in here. I think I've cut something when I was soldering. It's a very tight cabinet. Yep, I cut something. That wire. I just pulled it out of there. That's probably the other side of this, the string. So that's why the filaments on the pilot light isn't working. Okay, so I soldered the end of the filament string back to where it's supposed to go. So just because I want to make sure I did it right, I want to make sure it's not going to draw anything. It's not drawing much. It's hard to film that. We got pilot light, so that means that the filament string is now whole and it's not drawing much. So I think it's safe to say we can just go ahead and bring it up. Let's see if it's going to work. I don't hear anything. Let's see. Oh, ow. There we go.
May end up, and we'll talk about this later on in the show, but it may end up that they find themselves. There's no marriage in heaven. You have to make the same program.
Doesn't sound great. In fact, it sounds like there's a gassy tube. But the other thing could also be that there's a bunch of really, really desperately sick, melty looking capacitors in here. Look at that. I don't think those are capaciting in any form or fashion. Alright, so what I need to do is replace the rest of those. There's a lot of these in this thing. There's still like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more of these capacitors. It's not rocket science, it's just boring. So what you do is you look at the values. 0.01 rated microfarads at 400 volts. Just replace it with 0.01, 600 volts, 630, whatever. And just follow your values. I don't like this either, this kind of Mickey Mouse crap. I don't know, maybe the wiring's okay. It seems like it's supple. Let's go ahead and run this one to there. Why did they do that? When I see that, it makes me think like all they did is they twisted it together and there's no solder. So I'll definitely check that out. So I got to replace all these nasty old paper caps. And we'll try it again and see if there's any improvement. Well, I plugged this in and I got a pretty nasty hum again. And I looked and I was like, you know what? I remembered when I was looking at this initially, I thought it looked weird that one of the rectifier tubes looked like an output tube. And I looked at it and it is. So someone has stuck an output tube in the socket where the rectifier is supposed to go. So that's a great way to, that's probably where all these capacitors were melted. Look at that. So I need to find another one of those rectifiers, and I'm not sure if I have a 25Z6 in my stash. Here's what's stupid. They misprinted the label because I took a picture of this and used Google and whatever artificial intelligence to find the model. It's an H1-30, and there's supposed to be two output tubes, which makes sense. You got a bigger speaker, so it's push-pull audio. And if you look at it here, that's obviously the rectifier because that's one of the AC line coming in. We need to straighten out the juice coming into the set. So these two, those got to be our outputs. I'm pretty certain of it. So I need to find another 25L6. Then maybe it'll work. This is ridiculous. Alright, problem solved. Yay!
Information Network.
So that's probably all I want to do for it today. Maybe I'll clean clean up the cabinet a little bit. It's this lovely blonde cabinet. Which means I'll just touch it up with a little light furniture restoration product. Okay, long story short, I finished all the cleaning and polishing, and I've also added the audio input, which already existed on the set, through a isolation transformer, and it works.
Southbound
Here's radio.
direction. This is slightly past Leavesley Road.
Chase Bank NA member FDIC.
Information network.
Then here's audio input. All right. Thanks so much for watching this episode of Radiorama. See you next time.